Hello everyone. In today's session we will learn the T ratios when a triangle or right angle to triangle is given. So I have taken one example here. Let me read out the question for you. From the figure given below, find the values of sin theta, cos theta, tan theta, cot theta, sec theta and cosec theta. This is a right angled triangle PMO where the angle of reference is theta. Side OM is given 12 and side OP is given 15. Now we know that this side is the longest side and it is called the hypotenuse, and we can denote this one as H. This is the adjacent side and we can call this one base and denote it by B. So the side opposite to the reference angle will be the perpendicular, and we can denote this one by P. In order to find these trigonometrical ratios, we must first know all the sides. So we know the hypotenuse, we know the base, we do not know the perpendicular. To know this one, we will apply Pythagoras theorem first. So applying Pythagoras theorem in right angled triangle PMO, then we know this hypotenuse square, that is OP square, will be equal to PM square plus MO square. Now we need to find out what is PM. So we can write PM square is equals to OP square minus MO square, implies PM square is equals to, what is the value of OP? It is 15 square and the value of MO is 12 square. So we can write PM square is equals to, what is the square of 15? It is 225 and the square of 12 is 14, implies PM square is equals to 224 minus 144 will give us 81. Therefore, PM will be square root of 81, implies PM is equals to, what is the square of root of 81? The square root of 81 is plus minus 9, but we take only the positive sign because the side cannot be negative. So here we got this perpendicular now as 9. Now we need to find the trigonometrical ratios. But before we find out the trigonometrical ratios, let us first recapitulate what are these ratios. For that, there is a simple way to remember. If you just remember these lines, some people have curly brown hair turns permanently black. So how does this one help me to remember the T ratios? Some people have. S stands for sine, P for perpendicular, H for hypotenuse. So sine theta is perpendicular by hypotenuse. Similarly, cos theta is base by hypotenuse and tan theta is perpendicular by base. The other three T ratios can be obtained by knowing the reciprocal relation. So let us now start evaluating. So the first thing that we need to find out is the value of sine theta. So what is sine theta? Sine theta is perpendicular by hypotenuse, and in this case perpendicular is 9, hypotenuse is 15. So 9 upon 15, when we simplify, 3 3s are 9 and 3 5s are 15. Number 2 now. Number 2, we are finding cos of theta. So cos theta is base by hypotenuse. We can say base by hypotenuse also, and we can say adjacent side by hypotenuse also. Now how much is the base? Base is 12, hypotenuse is 15. So when we simplify, we get 4 upon 5. Now the third one, that is tan of theta. Tan theta is perpendicular by base. Perpendicular is 9, base is 12. So 3 3s are 9, 3 4s are 12. We get 3 by 4. Now the fourth one. We need to find now cot theta. So what is cot theta? Cot theta is reciprocal of tan theta. And how much is tan theta? 3 by 4. So the reciprocal of tan theta will be 4 by 3. Similarly, number 5 is sec of theta. Now sec of theta is the reciprocal of cos theta. And how much is cos theta? 4 upon 5. Cos theta is 4 upon 5. So how much do we write? 5 upon 4. The last one now. The last one is cosec theta, and cosec theta is reciprocal of sin theta. And how much is sin theta? 3 upon 5. So we write 5 upon 3. So this is how we can find the T ratios when a right angle triangle and its sides are known. Just want to make few things clear here. This sin theta, cos theta, tan theta, etc. are the operations done on theta. It does not mean sine into theta. These are not two separate identities. This is the sine operation done on theta, like we do addition, subtraction, multiplication and other operations in algebra. These are called trigonometrical operations. So these are not separate. Another thing, when we write these T ratios, all should be in small letters. We never write the trigonometrical ratios with capital letters.